Welcome to section 5.1. In this section, we are going to discuss the majority of the exponent rules. Before we would do those rules, though, I definitely want to go back and review exponents that we talked about way back in chapter 1. All right, so just a quick review. Remember, 3 raised to the 4th power is the same as 3 times 3 times 3 times 3. 3 is the base, that's the number that we're multiplying, and 4 is how many times we're multiplying factors of 3 together. So there's 4 factors of 3 that are multiplied together. Important to note that when we did order of operations back in section 1.4, that exponents come before multiplication. All right, so let's just recap, just to review a little bit. So again, 3 to the 4th power, that is 3 times 3 times 3 times 3. And if you want to put that in your calculator, please feel free to do so, but make sure you write out the definition so that you remember what's going on. That is 81. All right, -5 squared. Notice the parentheses are around the negative, so the -5 is the number. The base is not 5, the base is -5. So this is -5 times -5, and -5 times -5 is positive 25. All right, if you look at C, notice there are no parentheses this time, so only the 6 is squared, the negative is not. So this is -6 times 6, which is -36. So notice the difference between B and C. Notice having the parentheses versus not having the parentheses. Big difference in those problems. All right, D also kicks in a little bit of order of operations. Remember, do inside the parentheses first, so that would be 8 cubed. And 8 cubed is 8 times 8 times 8. And again, feel free to use your calculator on that. Most calculators have a power button, so please feel free to use that power button. That is 512. In E, notice we do not have parentheses, so we have to do the exponent first. So this is 3 times 4 times 4. And 4 times 4 we know is 16. 3 times 16 is 48. So there's your final answer there. All right, so just a little bit of recap of chapter 1 because I know it's been a little while. All right, evaluating expression we also did earlier in the chapters. We did some of these in chapter 1 and in chapter 2. So remember, when you're evaluating an expression, the first thing you're going to do is take that expression, and every place you see a variable, you're going to replace it with a set of parentheses. And inside those parentheses, instead of the x, we are going to put whatever value they tell us. So in this case, it's positive 5. So this, we have to do the square first. So this is 3 times 5 squared is 25, and 3 times 25 is 75. So there is our value. All right, same thing with B. We take our expression, replace every x with a set of parentheses, and inside the parentheses, we're going to put this time -1. So this is -2 times -1 squared. -1 times -1 is positive 1. So -2 times 1 is -2. So there's our final answer. So just, you can't forget all those skills because we're going to definitely use these skills in chapter 5. All right, so we are now going to start talking about the majority of our rules. So the first rule we're going to talk about, this is objective number 2, is the product rule. So the product rule is this right here. So really, this is all you need to write down. Don't worry about all this stuff at the top. This is just all the lingo I got straight out of the book. So this is the product rule right here. So if you look, we have a base raised to a power times that same base raised to a different power equals, we keep that base of a, and then we added the exponents together. So if you are multiplying like bases, keep the base was a, we kept that, and add the exponents. So if you're multiplying, you're going to add those exponents together. So that's the rule right here, and here is the explanation in human terms. So let's do a couple of examples of the this power rule for exponents. Product rule for exponents. Helpful hint, just a reminder that if there is no exponent, okay, if you just have an x, remember that is x to the 1st power. So don't forget. All right, so here we go. 3 squared times 3 to the 4th. Okay, so first question, do they have the same base? Yes, they have a base of 3. So you're going to keep that base, and then you are going to add their exponents, all right, 2 plus 4. So that is going to be 3 to the 6th power. Anytime you have a numerical base, you need to simplify that. And you can use your calculator, that's fine. Just put in 3 raised to the 6th power, and that gives you 729. So make sure you use the rule, and then if your base is numerical, put that in your calculator and spit out the answer. All right, same thing in B. Notice we have the same base, so we're going to keep the base, and we're going to add their exponents. So this is x to the 9th. We do not have a numerical base this time, so we just leave it right there. X to the 9th power, there's nothing we can do. Even if you have, like in example C, you have multiple z's multiplied together, that's fine. Doesn't have many. There could be 20 z's multiplied together. So if they're all z's, you're going to keep that base of z, and you're going to add up all those exponents. So this gives you z to the 10th power. 3 plus 2 plus 5 is 10. So that is the most basic explanation of the product rule. So we should do some examples that look a little bit closer to what you're going to see in real life. So here we go. I've got this term right here times this term here. Now notice we've got coefficients and we've got some variables here. So we're going to take all this stuff together. This is one big multiplication problem. This is 3 times y squared times -4 times y to the 4th. So anytime you have this situation where it's just one big multiplication problem, multiply your coefficients first and then multiply all the variable stuff. Oops, that should be a 4. Sorry about that. That should be a 4. Okay, so if you multiply your coefficients, you get -12. And if you multiply your variables, remember, you're going to keep the base and you're going to add these exponents. So 2 plus 4 is 6. So there is my answer. -12, y to the 6th. A lot of people ask, do they have to rewrite it? I definitely would. You are less likely to make a mistake when you're showing all of your steps. So same thing for B. Okay, this is one big multiplication problem. So I'm going to take the 6 times the -2 first, and then I'm going to take the x cubed times the x to the 9th. 6 times -2 is -12, and x to the 3rd times x to the 9th, same base. So we're going to keep the base, and we're going to add the exponents. 3 plus 9 is 12. So there is our answer, -12 times x to the 12th. All right, so if you feel like you understand, go ahead and press pause and give it a try. All right, welcome back. Again, same things. No coefficients on these two, so that's nice. So we're going to multiply the m's first. And remember, just m plain is m to the 1st power, so if you want to write that 1 in there, you can. You don't have to, but you can. And then I'm going to multiply my n's together. All right, so m to the 5th times m to the 1st is m to the 6th, right? Keep the base, add the exponents, times, same thing, and we're going to keep the n, add the exponents. So m to the 6th, n to the 18th. All right, in example B, we do have coefficients on both of these. So I have a -1 here and a 4 here. So I'm going to do -1 times 4 first. Then I'm going to multiply my x's, x to the 9th times x squared. And then I'm going to multiply my y's, y to the 1st times y to the 11th. All right, so multiply your coefficients, you get -4. Multiply your x's, that's x to the 11th. Multiply your y's, that is y to the 12th. So there's my final answer. -4, x to the 11th, y to the 12th. All right, the next rule is the power rule. Now, the power rule comes in a couple of different forms. So we'll talk about the generic power rule first, and then we'll talk about its cousins. All right, so the generic power rule is this right here. Okay, if you have a base raised to a power, and then that is all raised to another power, you are going to keep your base, right? The base is still a, and you're going to multiply those powers. So if you are taking a power raised to a power, you keep the base and multiply the powers. So let me show you some examples, and then I'll show you some other ways that you may see this power rule. All right, so here we go. Okay, so again, we have a power to a power, so we're going to keep the base of 2, and we're going to multiply those powers. 3 times 3 is 9. And again, because we have a numerical base, that means we can put it in our calculator, and 2 raised to the 9th power is 512. So there's our answer. Remember, anytime you have a numerical base, make sure you put it in the calculator. All right, same thing here. Keep the base, multiply those exponents. So my answer will be x to the 8th. All right, so that's the power rule. Pretty straightforward, nothing too fancy. All right, it does have two cousins, and that's what the next objective discusses. There's the power rule for products, and there's a power rule for quotients. So let's talk about those. All right, so if you have the power rule for a product, okay, power rule of a product, notice inside the parentheses is a product. We have a times b, and it's raised to a power. If that happens, you are going to give that power to both of those bases. So every factor gets a power of n. So the a gets an n and the b gets an n. So if you are taking a product raised to a power, each factor inside the parentheses is raised to that power. So one of my students called this Oprah a long time ago because everybody gets a power. So I've called it Oprah ever since then. All right, so if you look at this example I have at the bottom, we're taking this whole product and we're raising it to the third power. So the 5 is going to get the third power, the x squared is going to get the third power, and the y is going to get the third power. So once I've given everybody the power, then I just have to clean it up to make it look nice. All right, 5 raised to the third power. Again, you can put that in your calculator. That's 125. X squared to the third power. Remember, that's just the generic power rule right here. So we're going to keep the base, and we're going to multiply our exponents. And then y to the third. So there's my final answer. 125, x to the 6th, y to the 3rd. So if you feel like you're ready, go ahead and press pause, give it a try. All right, here we go. So everything in here is going to be squared. So the -5 is going to get squared. The x cubed is going to get squared. The y squared is going to get squared. And the z to the 4th is going to get squared. So we've given everybody a square. Now I just have to clean this up. So -5 squared, -5 times -5 is positive 25. X cubed squared, remember you're going to keep your base, multiply your exponents. So that's x to the 6th. Keep the base of y, multiply your exponents. So that would be 4. And then keep your base of z, multiply those exponents. That's the power of 8. So my final answer is 25, x to the 6th, y to the 4th, z to the 8th. All right, next example, same thing. This has a coefficient of -1. So -1 is going to get raised to the 6th power. The x is going to get raised to the 6th power. And the y to the 4th is going to get raised to the 6th power. So -1 to the 6th power. Again, make sure, if you're going to put it in your calculator, make sure that you use the parentheses around it. So -1 to the 6th power is 1. X to the 6th. And then y to the 4th to the 26th. Remember, we're going to keep that base y. We're going to multiply our exponents. When you put this answer in my math lab, you cannot have a coefficient of 1 or a power of 1. If you put a coefficient of 1 or a power of 1, it'll mark it wrong. So this would be the correct answer you would want to put in my math lab when you're working on the homework. All right, so that is the power of a product rule. All right, there is also a power of a quotient rule that works exactly the same way. That says if you have a quotient inside those parentheses, everybody gets the power. The numerator gets the power, and the denominator also gets the power. So again, everything inside the parentheses gets the power. So I have a short little example down here at the bottom. So we are going to give the numerator and the denominator that cube. So the p squared in the numerator gets the cube, and the v to the 4th in the denominator gets the cube. So we're just going to clean that up using the generic power rule. So we're going to keep the base, multiply our exponents. So you're going to get a p to the 6th in the numerator. And then in the denominator, again, keep your base, multiply your exponents. So there's my final answer. P to the 6th over v to the 12th. So there isn't much more to talk about that one. So we just have one more example to explain the power of a quotient rule. All right, so in this case, I always look to see if I can simplify what's inside the parentheses first. In this case, I can't. 2/3 doesn't simplify. X and Y are different bases, so they won't simplify. But I always check that first, just in case. All right, and then everything in the numerator is going to get this 4th power. So the 2 is going to get the 4th power. The x cubed is going to get the 4th power. And then everybody in the denominator is also going to get that power. The 3 is going to get that 4th power. And the y to the 5th is also going to get that 4th power. All right, so let's clean that up. 2 to the 4th power is 16. X cubed to the 4th. Okay, remember, keep the base, multiply your exponents. So there's your numerator, 16x to the 12th. And then do the same thing with your denominator. 3 raised to the 4th power is 81. We saw that earlier in this section. And then y to the 5th to the 4th, keep the y, multiply those exponents. So there is your final answer. 16x to the 12th divided by 81 y to the 20th. All right, objective number 5 is the next two rules. They actually put these two together. Okay, there's the quotient rule, and there is the zero exponent rule. The quotient rule says if you are dividing like bases, you are going to keep the base and you are going to subtract their exponents. So this right here inside the box is the quotient rule, and here is the definition in human words. Okay, this means if you're dividing like bases, keep the base and subtract the exponents, and it's always numerator, the numerator's exponent minus denominator's exponent. So if you think back when we did product rule, we were multiplying, which meant we added them together. This time we're dividing, so we're going to subtract them, which kind of makes sense if you think about it. All right, so here's a small little example at the bottom. So y to the 7th divided by y to the 3rd. Okay, so you're going to keep that base because they're both y's, and then you're going to subtract numerator's exponent minus denominator's exponent. So that's going to give you y to the 4th. All right, so that is the quotient rule. So let's going to practice this one for a couple of problems. All right, so here's the first example. All right, so first look, do they have the same base? Yes, they do. They both have a -2 in parentheses. So that's your base. And then you're going to subtract your exponents, 14 minus 10. So this is -2 to the 4th power. And feel free, again, to put that in your calculator. Make sure you have the parentheses and everything. So that is going to be positive 16. Remember, anytime you have a numerical base, make sure you're putting that in the calculator. All right, but this is a more typical example of how you're going to use the exponent rule. So if you see, we have 3 things that we're dividing. We've got coefficients, we've got bases of A, we've got bases of B. So I'm going to break it up into 3 problems. So I'm going to do 9 divided by 3, and then I'm going to do the A to the 4th divided by A, and then I'm going to do the B to the 7th divided by B to the 2. I'm going to kind of look at it as 3 small problems. So 9 divided by 3 is 3. A to the 4th divided by A. Again, if you need to, this is A to the 1st power. So 4 minus 1 would give me A to the 3rd. And then here the B's, keep your base of B. 7 minus 2 would give me 5. So there's my final answer. All right, so here's one almost identical to that last one. So if you'd like to, press pause, give this one a try. All right, so again, I'm going to break this one up the same way. I'm going to look at those coefficients first, and then I'm going to look at the x's, and then I'm going to look at the y's. All right, so -24 divided by 8 is -3. And then the x's, 7 minus 3 is 4th power. I almost put 3. There we go. And then the y's, 5 minus 2 is 3. So there's my final answer. -3, x to the 4th, y to the 3rd. All right, the zero exponent rule says that anytime you have a base raised to the 0 power, it is 1, as long as your base is not 0. So for any non-zero base, no matter how complicated it is, I don't care if it's just a number, if it's just one variable, if it's a variable times another variable, it doesn't matter. Okay, if any base raised to the 0 power is 1. Important to note that 0 to the 0 power is undefined. We don't talk about that in this class, but there are other classes where we'll talk about what happens when you have a 0 base. But we in this class, we're only going to look at non-zero bases. So here are a couple of examples. So 5 to the 0 power, again, that is 1. Base to the 0 power is 1. B, notice our base is this big, huge product, but that's still the base. Any base raised to the 0 power is 1. Okay, it doesn't matter that that base is this big, huge thing. Okay, as long as it's inside those parentheses, that whole base raised to the 0 power. Notice this one, though, there's a negative and it's not inside the parentheses. So this is the -1 times x to the 0 power. Okay, there's a 1 right there. So this is -1 times 1, which is -1. So be careful, again, just like we talked about at the very, very beginning of this section, having parentheses around your base versus not. Okay, there are differences, so make sure you keep that in mind. So here's a couple of test-like questions that you could see that use the 0 exponent rule. So here, notice this entire base, 8m, all in parentheses. So that base raised to the 0 power is 1. Some people would say, well, what if you don't remember that? Okay, you would use the power of a quotient rule, right? The 8 would get the 0 power, the m would get the 0 power. Well, what's 8 to the 0? That's 1. M to the 0, that's 1. 1 times 1 is 1. So notice, you still get exactly the same answer. I just think that the way at the beginning is much easier and it's going to save you time. All right, next example. Notice the only thing that's raised to the 0 power in this is x. So this is 5 times 1 times y to the 5th. So that is 5y to the 5th. So remember, it's only the base that has the 0 exponent becomes 1, nothing else. So just be really careful with these. Again, you have to look for the parentheses, no parentheses. All those little tiny nuances matter when it comes to algebra. All right, at the end of this section, they're going to kind of mix all those rules together. So you're going to have to be able to look at it and figure out what's going on. All right, so let's kind of look at a couple of examples. No, I'm not telling you which rule to use. So take a second, look at A. Okay, and tell me which rule that you should be using on problem A. Okay, hopefully you said the quotient rule because we are dividing. So when we are dividing, we keep the base, we subtract those exponents. So that is x cubed. Okay, that is the quotient rule for exponents. All right, let's look at B. What rules should you use for B? Hopefully you said the power of a product rule. Okay, that's Oprah. Everybody's going to get a power. The 3 is going to get the 4th power. The y to the 4th is going to get the 4th power. Okay, 3 to the 4th power is 81. And y to the 4th, remember, keep the base, multiply those exponents. So there's my answer, 81, y to the 16th. And what about C? What rule do I use there? Hopefully you said the power of a quotient rule. Okay, you got a quotient. So the numerator is going to get the power. The denominator is going to get the power. So that is x cubed over 4 to the 3rd power is 64, right? I don't know. My brain doesn't work. This is why I have to use a calculator all the time. Yes, that is 64. Good. All right, so there's my final answer. X cubed over 64. So this is the kind of stuff you should start expecting, where they're not going to tell you which rule to use. You're just going to have to be able to look at the problem and know. They're just going to say simplify. They're not going to give you any hints. All right, so let's ramp it up a notch. And I know that looked like maybe I went up a couple notches, but I only went up 1 notch. So let's look at the first problem, A. 4 to the 4th minus 4 to the 0. So first of all, what is 4 to the 4th power? I don't know off the top of my head, but I do have a calculator. So 4 to the 4th power is 256. So that's 256 minus, all right, 4 to the 0 power. 4 to the 0 power is 1. So my answer is 255. So in this problem, all I did was use the definition of an exponent and I used the 0 exponent rule. So sometimes you'll have to use more than one thing. You may have to use a definition with the rules. So keep all that in mind. All right, B. When I see this problem, the first thing I see is I have powers to powers. So that's the first thing I'm going to look at. Powers to powers. So x to the 0 times 5 is 0, plus, keep the base, multiply, 0 times 6 is 0. X to the 0 power is 1, 3 to the 0 power is 1, and 1 plus 1 is 2. So there's my final answer. Now, that being said, you may have approached this problem differently. So let me show you an alternate way to do the same problem. And this is where most people have a hard time with exponent rules, because it's not like order of operations where you have to do it in a certain order. You can use these rules in any order you want, as long as you don't break the rules. So if the first thing you saw was x to the 0 power, that's 1. So that's 1 to the 5th power plus. 3 to the 0 power is 1. That's 1 to the 6th. Well, 1 to the 5th power is 1, plus 1 to the 6th power is also 1, so 1 plus 1 is 2. Notice I got exactly the same answer, but I did it entirely different ways. They're both acceptable answers. So please know that if you are working on this with a friend and you're doing the same problem and they do it completely different than you do, but you both get the same answer, you're both right. Okay, there's not one right way to show the work on these problems. All right, let's look at C. Okay, so I've got a numerator and a denominator, and I noticed that the numerator has a power, so I'm going to probably have to clean that up first. So let's just look at that numerator. All right, so the numerator, the 2 is going to get the 3rd power, the a cubed is going to get the 3rd power, the b to the 4th is going to get the 3rd power. So I'm going to write it down here so I have some more room. So the numerator, 2 cubed is 8, a cubed cubed is a to the 9th, and b to the 4th cubed is b to the 12th, right? 4 times 3. All right, and now let me rewrite my denominator. And this looks a lot like those division problems I was just doing a couple slides back. So first thing I see is that the a to the 9ths are identical, so those are going to divide out. So I don't even have to worry about those. So first thing I have to do is 8 divided by -8 is -1 times b to the 12th divided by b squared. I'm going to keep the base. I'm going to subtract those exponents. So my final answer is -b to the 10th. Remember, if you write -1, my math lab will probably mark you wrong. So remember, no 1 coefficients, no 1 powers, okay? All right, so I tried to come up with some extra examples that look a lot like previous test questions, just so you kind of have an idea of what's going on. So if you'd like, press pause, try them on your own first and see how you do. All right, welcome back. Let's look. Okay, so we've got, this is the product rule that we were doing at the very beginning. So we're going to do this, multiply your coefficients, multiply the x's, multiply the y's. And remember that x does have a power of 1, so we're going to write that in. So we multiply the coefficients, we get 35. We're going to multiply our x's, we get x to the 4th. Multiply your y's, that's y to the 11th. So my final answer is 35 times x to the 4th times y to the 11th. The next example was a power of a product. So everything inside the parentheses is going to get that power of 6. So the 2 is going to get the power of 6. The x cubed is going to get the power of 6. The y is going to get the power of 6. So 2 raised to the 6th power is 64. X cubed to the 6th power, we're going to keep the x, multiply those exponents, and then y to the 6th. So there's my final answer. 64, x to the 18th, y to the 6th. All right, here are the next 2 examples. If you would like, press pause, try these first, and then come back and we'll see how you do. All right, welcome back. So first thing I notice is that I have parentheses here that I need to get rid of. So p squared times, all right, when I have a power to a power, you keep the base, you multiply the powers. And then I'm multiplying the like bases, so I'm going to add their exponents. So keep the base, add their exponents. So there is my final answer, p to the 12th. Hopefully you got the same answer I did. All right, the next one is the power of a quotient. I've got everything inside the parentheses is going to get that 5th power. So the 3 is going to get the 5th power, the x to the 4th is going to get the 5th power, and that y to the 6th in the denominator is also going to get that 5th power. So we just need to clean that up. So 3 raised to the 5th power is 243. X to the 4th to the 5th is x to the 20th, right? 4 times 5 is 20. And then in the denominator, we have y to the 30th. So there's my final answer. 243 x to the 20th over y to the 30th. And our last example. All right, so press pause and give it a try. See you in a minute. All right, here we go. First thing I notice is that both of these parentheses have powers. So I definitely need to get rid of those parentheses first. So first thing I'm going to do is everything here is going to get a square. The 3 is going to get a square. The x cubed is going to get a square. And then over here, the 2 is going to get a cubed, and the x is going to get a cubed. So I'm going to clean all this up first before I do anything else. So 3 squared is 9. X cubed squared is x to the 6th. And then here, 2 cubed is 8. X cubed is x cubed. All right, so just like before, I'm now going to multiply my coefficients, 9 times 8, and then I'm going to multiply the x's. So my final answer is 72x to the 9th. All right, hopefully you have the same answer I did. All right, so now you know most of the exponent rules. There is one more rule left, and that is covered in section 1.5. So we will see you back for section 1.5 in a little bit.